Deep in ancient Australian landscapes, a shadow stretched across the sun-baked earth from an immense predator. Even the largest kangaroos and wombats could not escape the gaze of this colossal hunter's presence. This was Megalania, a monitor lizard that ruled Pleistocene wilderness with silent and utterly lethal precision. Measuring far beyond any living reptile, it hunted, scavenged, and survived in a world of giants. How did this extraordinary creature evolve? And what secrets lie hidden within its fossilized remains today? Today we journey back more than 1 million years to uncover the story of Megalania completely. This ultimate terrestrial lizard reveals a fascinating blend of paleontology, evolution, and predator-prey dynamics here. These forces shaped Australia's prehistoric ecosystem in ways we are only beginning to understand through research. Monitor lizards rank among the most remarkable reptiles alive today for their impressive size and intelligence. Their adaptability and evolutionary history make them fascinating subject for scientists studying reptile evolution across millennia. The largest living monitor, the Komodo dragon, can reach nearly 3 meters in total body length. Yet in prehistoric times, their relatives grew to staggering proportions that dwarf modern species entirely today. One of the most awe-inspiring giants was Megalania, a lizard so massive it earned legendary status. It has been dubbed the largest terrestrial reptile ever to walk upon the Earth's surface. Fossils of Megalania have been known to science since the 19th century, sparking continuous scientific interest. In 1859, the legendary naturalist Sir Richard Owen first described the species from bones discovered. These bones were uncovered in southern Australia, giving it the name Megalania Prisca for scientific classification purposes. Over the decades, new discoveries have revealed that this giant lizard persisted far longer than imagined. It survived until approximately 50,000 years ago, sharing its world with early humans and megafauna. This timeline places Megalania among the most recent giant reptiles to walk Australia's ancient landscapes. Despite its fame, the fossil record of Megalania is frustratingly incomplete, leaving many questions unanswered today. Most specimens are fragmentary, leaving paleontologists to reconstruct its appearance and size from scattered bone fragments. Yet even from these fragments, we can discern a formidable predator with remarkable adaptations for hunting. Its skull carried pronounced ridges, much larger than those of its modern relatives living today worldwide. The humerus was unusually wide, suggesting immense strength in its forelimbs for grasping and attacking prey. Osteoderms, small bony plates embedded in the skin, offered protection around its head and neck region. This trait is shared with modern monitors, providing insight into their defensive adaptations against predators. Its teeth, curved and razor-sharp, featured wrinkled enamel that would have ensured lethal efficiency always. This design proved ideal for tearing flesh from prey animals during feeding and hunting activities. Estimating the size of Megalania has long been a topic of intense debate among scientists. Without a complete skeleton, researchers rely on scaling from close relatives like the Komodo dragon today. Early estimates suggested lengths up to 11 meters, though more conservative calculations revised these figures downward. Studies in the early 2000s placed it between 3.5 and 4.5 meters. Later research expanded this range again, suggesting a body length closer to 7 or 8 meters. Mass estimates surpassed half a ton, making it an incredibly heavy reptile for its time. Regardless of the exact numbers, it is clear that Megalania dwarfed all living terrestrial lizards completely. But how did this prehistoric giant fit into the evolutionary tree of monitor lizards worldwide? Megalania belonged to the Varanus family, a diverse lineage of carnivorous lizards spanning Asia, Africa, Oceania. Its closest living relatives were long debated among paleontologists studying monitor lizard evolution and classification. Some paleontologists proposed a link to the parentage, the largest lizard still roaming Australia today. However, Modern analyses of skull morphology indicate a closer relationship to the Komodo dragon specifically. This unites the giant Indo-Australian monitors into a single evolutionary cluster with shared characteristics throughout. This relationship provides valuable insight into the adaptations that allowed Megalania to dominate its environment successfully. Interestingly, the classification of Megalania itself has shifted over time as scientific understanding has evolved. While Owen initially named it Megalania Prisca, many scientists now argue it belongs in Varanus. This makes its formal name Varanus Prisca, aligning it with all modern monitor species worldwide. Yet for storytelling, the name Megalania evokes the awe and terror inspired by unprecedented scale. This creature's size continues to capture imaginations and inspire wonder among scientists and enthusiasts alike. As a predator, Megalania would have resembled its modern cousins in both hunting strategy and diet. Fossil evidence indicates it preyed on a range of animals, from small reptiles to marsupials. Its hunting methods may have been similar to the Komodo dragon, which relies on stealth. Strength and venom combine to make modern Komodo dragons highly effective predators in their ecosystems. Modern Komodo dragons possess a complex venom delivery system along their teeth, a hemotoxic cocktail. This venom prevents blood clotting and weakens prey, making kills more efficient and reducing risk. By comparing skulls and teeth, scientists hypothesize that Megalania shared this deadly adaptation throughout its existence. This makes it the largest venomous vertebrate known in history, a truly remarkable evolutionary achievement. The venomous bite, combined with powerful limbs and an imposing size, made Megalania nearly perfect. It functioned as an apex predator capable of taking down the largest prey in Australia. Fossils suggest it could ambush animals like kangaroos, delivering a bite that would gradually incapacitate victims. In addition to hunting, Megalania likely scavenged carcasses, ensuring it exploited every opportunity for survival. This behavior pattern mirrors modern monitors in challenging Pleistocene landscapes where food was often scarce. Yet even this apex predator eventually vanished from the Earth, leaving only fossils behind today. The causes of Megalania's extinction remain uncertain, though humans may have played a significant role. Evidence shows that humans arrived in Australia around the time Megalania was still extant there. While direct encounters are not documented, overlapping timelines suggest the possibility of hunting pressure or disruption. Habitat disruption may have contributed to the lizard's decline over thousands of years of coexistence. Climate change may also have played a part, altering ecosystems and affecting the availability of prey. Megalania's extinction marked the end of an era for Australia's giant reptiles, closing a chapter. But its legacy remains in the living monitors we see today across Australia and Indonesia. The Komodo dragon, parenti, and other large lizards carry the genetic heritage of ancient lineages. This lineage once produced monsters capable of reshaping entire ecosystems through their predation and scavenging behaviors. Studying Megalania not only illuminates the biology of extinct species, but enhances our understanding significantly. Predator-prey dynamics, evolutionary adaptation, and the delicate balance of prehistoric environments become clearer through study. Fossils, though incomplete, allow scientists to piece together the story of a creature inspiring fascination. Each bone, tooth, and ridge provides a clue to how Megalania moved, hunted, survived. Over hundreds of thousands of years, this predator dominated Australian landscapes with remarkable efficiency and power. By examining these remnants, we witness the power of evolutionary forces and remarkable diversity of life. This diversity has existed on our planet across millions of years of Earth's history. Through modern techniques, researchers continue to refine their understanding of Megalania's biology and behavior patterns. Computer modeling, comparative anatomy, and fossil analysis allow paleontologists to simulate its movement and capabilities. Bite force and hunting strategies can be reconstructed through these advanced scientific methods, and techniques. These studies reveal a predator optimized for efficiency, a reptile that could challenge large mammals. In many ways, Megalania serves as a window into a vanished world long gone. It stands as a testament to the extraordinary forms life can take when adaptation favors innovation. The story of Megalania also offers broader insights into the evolution of venomous reptiles worldwide. Its probable venomous capabilities illustrate how predation strategies can evolve to maximize efficiency without brute force. This is particularly evident when we compare Megalania to modern Komodo dragons in hunting techniques. They utilize a combination of laceration, venom, and patience to bring down prey with efficiency. In this way, Megalania represents both continuity and specialization within the monitor lizard lineage today. From the jagged ridges on its skull to the curved, serrated teeth, every feature mattered. Every anatomical feature of Megalania was fine-tuned for survival in harsh prehistoric Australian environments. Its limbs suggest powerful locomotion, capable of sudden bursts of speed for ambushing prey effectively. Its osteoderms offered defense against rival predators and the occasional struggle with large, dangerous prey. Even the structure of its jaws, though not built for crushing force, was ideal. It resisted the stresses of repeated biting and tearing, a remarkable combination of form and function. Fossil discoveries also hint at the social and ecological context in which Megalania lived successfully. Australia's Pleistocene landscape teemed with megafauna, from giant wombats to enormous kangaroos, providing abundant prey. Yet life was not without challenge for even the most powerful predators in this ecosystem. Fluctuating climates, changing vegetation, and the arrival of humans created pressures that may have contributed. These dynamics remind us that even the mightiest predators are not immune to environmental change. As we explore Megalania's story, we are struck by the interplay between size, intelligence, predation. Unlike many reptiles, monitor lizards demonstrate remarkable problem-solving abilities, which may have extended to Megalania. Hunting strategies, territorial behavior, and scavenging tactics likely required cognitive skills beyond mere instinct alone. This combination of size, strength, and strategy sets Megalania apart from other prehistoric reptiles. It highlights Megalania as one of the most formidable reptiles to have ever existed anywhere. Yet beyond its biological marvels, Megalania captures our imagination because it challenges what we consider possible. A creature capable of killing large mammals, resisting environmental pressures, and thriving for millennia exemplifies innovation. It reminds us that Earth's history is filled with astonishing life forms adapted extraordinarily. Each was adapted in extraordinary ways to survive and dominate their ecosystems across geological time. Today, Megalania lives on in science, in museum displays, and in imaginations of prehistoric enthusiasts. Its fossils are more than mere bones. They are narratives etched in stone for eternity. They tell tales of survival, power, and the intricate web of life that existed long ago. By studying these relics, we connect with a past both alien and familiar to us. It was a time when giant lizards roamed freely across vast, untamed landscapes without competition. As we delve deeper into the biology, ecology, and evolutionary significance of Megalania, discoveries continue. We uncover the fascinating ways in which this species mirrors and diverges from its relatives. Each discovery adds nuance to our understanding, revealing a predator that was both extraordinary and adapted. From venom delivery systems to skeletal morphology, the giant lizard exemplifies evolutionary specialization at extremes. Megalania also serves as a reminder of the delicate balance between species and ecosystems. The extinction of such a dominant predator reshaped Australia's Pleistocene ecology, influencing prey populations dramatically. The dynamics of other carnivores shifted as well, creating cascading effects throughout the ecosystem. Its disappearance illustrates how the loss of a single apex predator can reverberate through ecosystems. This alters evolutionary trajectories for millennia, affecting species that survive and evolve in its absence. In many ways, studying Megalania is an exercise in imagination grounded by scientific rigor today. Paleontologists must reconstruct its life from fragments, hypothesizing behaviors, diets, and hunting strategies with care. They constantly test these ideas against comparative data from living monitors, refining theories with evidence. This process transforms what might be mere speculation into evidence-based insights, bridging gaps between disciplines. It connects history and biology, fossil and living organism, past and present in meaningful ways. Finally, the story of Megalania reminds us of the extraordinary diversity that once existed here. From massive reptiles to giant marsupials, Pleistocene Australia was a world of giants everywhere. Each species pushed the boundaries of size, predation, and adaptation to survive in challenging environments. By studying Megalania, we glimpse the extraordinary possibilities life can achieve when evolution experiments freely. It leaves behind creatures that continue to fascinate millions of years later across the globe. Megalania stands as a testament to the power and mystery of evolution dominating its world. Though extinct, its story echoes through the bones of its descendants, the Komodo dragon worldwide. It reminds us of Earth's ancient wonders that shaped the natural world we know today. By exploring these lost giants, we connect with a past that continues to influence life. We are inspired by the incredible diversity and resilience of the natural world across time.